Alright, this lecture is going to cover video and sound definitions. And first we're going to start with types of video displays that we can use. So the first video display is CRT, and we don't see a lot of those anymore. Those are the big old clunky monitors, but there are a few things you need to know about them because they are still covered. So this basically shows you the internals of the CRT monitor and how it works. You have, CRT stands for cathode ray tube, and essentially what you have is you have a ray gun, and it shoots electrons at this device here, and this is actually made up of several items. You have a shadow mask and an aperture grill, and so the electron gun shoots the electron beams at this, and then what it does is it splits the colors up, and the shadow mask is basically just a mask with a bunch of slots in it, and then you have an aperture grill which blocks stray electrons so that only the appropriate electrons get through, and it lights the pixels up. You don't want parts illuminated that shouldn't be, and so you have the different components that make that up. That's the basics of it. There are some other components in here like a giant capacitor. So one of the things we need to know about CRTs is that we don't work on them. We do not take them apart. You could become electrocuted. It is not a good idea. Other things that we do with CRTs, occasionally we have to do something called degaussing, and this is demagnetizing the shadow mask to realign the dots, and the dots are the pixels, and you'll see this pixel right here. If you've ever seen a CRT TV or computer display where there's color distortion in the corners, or it starts to look a little bit fuzzy and distorted, there's a button on the front. You have something called the OSD, the on-screen display, and you have buttons on the front of your monitor, and you can play with those buttons, and it gives you some options to change different aspects like brightness and where the picture sits on the display. You can adjust that, and you can do something like degaussing. And LCDs have something similar. It resets the image. But it's not the exact same because they don't use the same technology. So you have an image reset on an LCD, but you do degaussing, which is a physical process on a CRT. So important aspects of a CRT monitor: what resolution can the monitor display? So you have certain lists of resolutions, and those are in your book, and those, for example, those are going to be things like XGA, which is 1024 by 768, which was a pretty high resolution for a lot of CRT monitors. I think most of them capped out right around 1600 by 1200. Those were some of the bigger, higher-end CRT monitors, Sony Trinitrons. You could display some of those higher resolutions. So the resolution, so I said, for example, 1024 by 768. That's 1024 pixels across the screen and 768 pixels down. And then, of course, the higher your resolution, the crisper your picture is going to be, because the smaller your individual pixels will be. Your monitors do have certain resolutions that they can display. You actually have two aspects going on here. Your monitors have resolutions that they allow, that they're capable of displaying, and then your video card has resolutions that it's capable of displaying. And your highest resolution you can display is going to be whichever one is your limiting factor. So whether it's your video card or your monitor. The other item you have with the CRT is your refresh rate. So for the image to stay on the screen, it gets rewritten. And you can kind of see this in this image with the gun, where it's writing the image onto the screen. So this is your vertical refresh rate. It's how much time it takes to go from the upper left-hand corner, draw the entire image, and then get back to the upper left-hand corner. And standard refresh rates are somewhere in the range of 60 hertz to 85 hertz. And the thing with a CRT monitor is that if you go too low on your refresh rate, you get flickering. If you go too high on your refresh rate, it can actually damage the monitor. So you have to find that nice middle ground, and somewhere around 75 hertz was the proper refresh rate. Once again, you are limited as to what your video card can do and what your monitor can support as well, as to what refresh rate you get to choose. The other thing about CRT monitors, because they do use an electromagnetic process, they're susceptible to EMI. And so CRT monitors that are near power lines, they can, it can cause flickering and interference with the monitor. That can be kind of annoying. Most of the time we don't have this much problem anymore because we all use CRTs. Alright, dot pitch. So you have the pixels in here, and actually if you were to take the pixels and put them in a triangle, you would have the dot pitch is the distance, the angular distance between the two pixels. So if I were to put, say this was a red pixel, and this was a green pixel, and this was a blue pixel over here, and then I would have another blue pixel over here, this distance between these two blue pixels would be the dot pitch. So a good dot pitch was somewhere between 0.15 and 0.30 millimeters. I remember getting one that was at like 0.22 and I was all excited. That was a really good monitor. So the better the dot pitch, or the lower the dot pitch, the crisper the screen. It's a better image. CRTs are analog monitors, so do be aware of that. You're going to use a VGA type connector. That's a 15-pin 3-row connector. It's colored blue. Other adjustments you can make, the contrast. So contrast is basically the difference between the black is black and the white is white. Brightness, how bright the image is on the screen, and image position. So you can, especially with CRTs, they would show up and it would be moved over. So this would be black space, and then part of the image would be moved off the screen. And you can use the on-screen display to adjust where the image sits on the screen and kind of expand it out. Alright, so our next one is LCDs, and I just pulled up a quick, how an LCD works. So you can see the different components that go into making up the LCD. You have polarizing films, you have glass, you have mirrors, and then you actually have the liquid crystal layer. The other thing that you have to have is a light source. This doesn't really show that. So back behind all of this, you're going to have some sort of light source, potentially. You have two different ways that LCDs can be lit up. They can be backlit or they can be edge lit. So most of them tend to be edge lit. So you have lights up at the edges of the monitor. So either a side edge or the top edges, usually not all four. And so the light is directed from the sides. You can have backlit displays. Those are actually LED monitors, and so you'll have an LED panel from the back. LED monitors can also be edge lit though, and most of them are. The backlit ones, the full backlit panels, are pretty expensive because it's a full panel of LEDs in the back. The beautiful thing about them is that, especially with TVs, large TVs, you don't notice it on a monitor that this size. This is a 22-inch monitor, and it's not really big enough for you to be able to see issues at the corners. But on a lot of TVs, you'll see bright spots in the corners when they're edge lit, because that's where the light meets. So a backlit is generally a better display. It's going to give you the more truer blacks and no color distortion throughout. Alright, so beautiful things about LCDs. They use much less power, which means they generate less heat, they take up less space, you have less glare, and they emit less radiation, which is always great. What considerations for LCDs is viewing angle. This used to be a huge issue, and it's not so much anymore. So how far to the side of this can I stand and still see the image? That's the viewing angle. What angle am I at on the TV? Do I have to be directly in front of it? Do I have to be at a 90-degree angle to be able to see it? Or can I be over here at maybe a 15-degree angle and still see the image on the screen? And they've gotten really good, and so your viewing angles have gotten really small, which is excellent. Other considerations for LCD is response rate. And this is the speed at which the pixels change colors. It's measured in milliseconds. This is similar to the refresh rate, but with an LCD, we don't draw the picture on the screen. We just digitally tell it, it's a digital display, so we digitally tell it to light up certain pixels to get the display on the screen. Well, we need to know how fast those pixels respond to the command to light up. So basically, the response rate is measured in how quickly the pixels can go from all black to all white to all black. And most LCD monitors today, the response rate's around 2 milliseconds. It's really low. When they first came out, you know, a 20 millisecond response rate used to be really awesome. And I remember buying one with, you know, somewhere in the low 20 millisecond response rate, and it was very exciting. But now they've come down, and even your cheapest LCD monitors have a, you know, that 2 to 5 millisecond response rate. Some even down to 1. Once again, we still have contrast ratio. So this is the ratio between the monitor's whitest white and darkest black. Higher contrast ratio is better. Standard LCDs have somewhere in a 40,000 to 1 contrast ratio. Now with CRTs we have supported resolutions, and you always wanted to go with your highest resolution possible. That was always going to be the best looking one. With LCDs we actually have native resolution. So the native resolution is the one at which the pixels are set. You have a set number of pixels in an LCD, and so if you set your resolution lower than what your native resolution is, what it does is it groups the pixels in order to come up with less pixels on the screen. So if my native resolution is 1920 by 1200, then I should run it at 1920 by 1200. If I lower my resolution to, you know, 1440 by 900, it's going to look choppy. It's going to look bad. It's going to look fuzzy. There are ways to deal with that. They have a technology called anti-aliasing that will smooth the jagged edges out, because basically you're blocking up the pixels. The pixels are little squares. If you've ever had a pixel go out in your monitor, you'll see, you know, well, you can't see this, but I can see a little piece of dirt on my monitor right here, but it looks either black, red, green, or blue, and that's, if they're colored, they're stuck. If they're black, they're out. It's something to consider when you buy an LCD. Personally, I like to buy my LCDs from Costco, because if anything's wrong with it, I can take it back. Some other places you buy LCDs, Newegg, Best Buy, some of those, they have a policy that you have to have, you know, a certain number, around 5 or 7 stuck or dead pixels before they will return the monitor. And I can tell you, even 1 pixel, even up in the upper corner where it would seem like it wouldn't be bothersome, is annoying as all get out. Just having that one little red, green, blue, or black spot in your monitor is infuriating. When they're stuck, there are some things you can do. There are programs out there that you can use to fix stuck pixels, and basically they're little flash programs that flash the monitor, and you can see, and so it'll flash in colors. I'm not going to turn it on because it'll give everybody a case of epilepsy. But you can see the colors, and it'll flash the whole screen in blue, green, red. It'll do lines, it'll do sections, and it just flashes it, and it flashes over and over again. And the idea is to try and get that pixel to respond by quickly changing the screen over and over again. If it's black, it's dead. There's nothing you can do. Another way you can fix a stuck pixel is to take the eraser end of a pencil, and you can massage the pixel, and sometimes that will unstick it as well. Alright, so native resolutions, you cannot set your monitor higher than your native resolution. That is the highest resolution it supports. and lower, it will look not so great. We have a couple different other monitor types that I threw on there that I'm just going to give some honorable mentions to. We have OLED, which is an organic LED. These are really cool because they can essentially be printed on just about any substrate. We could have flexible monitors. They're ultra thin. They emit their own light. They don't have an external light source like an LED or an LCD monitor has. They use a conductive layer to emit the light. They do have a lifespan. At some point, it's going to decompose to the point that it emits no light, and therefore you have no monitor. But they have a pretty good lifespan on them. They're very expensive right now. They're starting to come down in price, but we're not quite there yet. But they're very impressive. And then plasma. This uses fluorescent lights. But displays similar. The display works similar to an LCD. It's known for brightness. They're very bright, and then also low luminance black levels. They have really great blacks. Plasma TVs are very impressive. It looks like you're there. They're wonderful. The problem with them is that they use a lot of energy. If you have a plasma TV and you've had it on, you turn it on, it's been on for a little while, walk up to it. I mean, it is definitely a force to be reckoned with. I'm pretty sure my power bill went up quite a bit when we got the plasma TV. All right, so projectors. So the other thing that we have is video projectors, LCD projectors. We have one of these in our classroom, and the projector, so it uses LCD panels on the inside, and you have a lamp in there. This is not a light bulb. It's called a lamp. They are very expensive. They run, somewhere in the $200 to $500 range, depending on what kind of projector you have. You don't want to touch them. You'll damage them, kind of like a halogen light. And what this does is this puts the light out, and then you'll see that you have different LCDs, and it splits the colors out, and then you have these mirrors. And the mirrors are called dichroic mirrors, and they reflect light in some wavelengths and permit light in other wavelengths. And so basically they split all the light out, and then it comes through here. And this picture doesn't actually show it, but you actually have a device that combines everything that's left over to point the image out. And then that displays the image. So there are three aspects to projectors that we should discuss. And those three aspects are lumens, throw, and the lamp. And I already mentioned the lamp. And the lamp is your light source. And it's rated in lumens. And the higher lumens, the better the light source. It's going to be brighter, so that you can use the projector in a bright lit room. So in our classroom, I have to turn the front lights off. Otherwise, you guys would never see the projector. But the better projectors, newer projectors, you can leave lights on and see the projector, no problem. So the throw. The throw is basically the size of the picture at a certain distance. So if the picture is 10 by 10 on the wall at 10 feet, you get a throw ratio based upon that. And so you want to inspect that. You want to see, when you buy a projector, how close or far away does the projector need to be in order to get a picture of a certain size. And that's basically it with the LCD projectors. You can buy really inexpensive ones. You can buy really, really expensive ones. You can get, larger sized ones. If you're going to mount it in the ceiling, you don't really care that it's larger. You can get projectors that literally will practically fit in your pocket. Projector technology has come a long way. It's pretty fascinating. And you will support them a lot because they're used in all business sense. Everybody's got meetings. Everybody's got to do death by PowerPoint. So everyone needs projectors. And then they have the same connections that, you know, a standard display has, you know, so you can connect them via HDMI, you can connect them via DVI, VGA, you know, any of the standard connections options. Okay, so let's talk about some of our connectors that we have here. I've got pictures of some HDMI outputs and some DVI connectors on here. And I didn't put one up of VGA. So VGA was our old style. That was the blue connector. I'll pull one up. So you see these are our VGA connectors. This is three row, 15 pin. And this is an analog signal. You can go up to Super VGA, so this can display up to 1600 by 1200. You know, we've pretty much outpaced this. You know, we try not to use this if we can help it. For the most part, now we're going with DVI. So we have some different flavors of DVI. DVI stands for Digital Video Interface. We have DVI-A, DVI-D, and DVI-I. DVI-D is what we generally use now. DVI-I is interchangeable. It can display analog or digital. And then DVI-A was one we had in the very beginning. It was analog, which is very strange. It converted, basically. So it did an analog conversion. And so everything was analog. And you don't see that very often anymore. You're pretty much just going to see DVI-I and DVI-D, and primarily DVI-D. We have two different kinds you'll see on here. It says single link and dual link. Dual link just displays a higher resolution. Single link is capable of 1920 by 1200. Dual link up to 2560 by 1600. So we see these very commonly on our video cards and our monitors. The other technology that we see very commonly is HDMI. And the beautiful thing about HDMI is that not only is it deliver video at high definition, but it also has 8 channels of audio. So we can push audio over HDMI. And we love that. It's very exciting. One connector for both our video and audio. So we have some standard HDMI, we have mini HDMI, we have micro HDMI, so you can see the different connector types. This is the one that most people are familiar with, you see on your TVs. You do have some different types. We have A, B, C, D, E. And they have different pinouts and they have different resolutions that they support. Obviously, you have more pins with a B. This will actually support resolutions up to 3840 by 2400, and A does 1920 by 1080, so that should be 1080p. And I think this is the more common connector. A few other honorable mentions that we want to throw out there. Component, your component connector. This uses RCA cables. It does high resolution up to 720p, but it is analog. Also, you have S-Video, and sometimes you'll still see S-Video on your video cards. And this is something you commonly see in TVs and VCRs. It's a decent video standard if you don't have another option. And then your lowest quality is going to be composite, and this just uses a single RCA cable, and it is pretty low quality, and we don't see that much anymore. Okay, so next, let's talk about the video cards themselves. So I've kind of gone out of order. So let's start with the video bus. So I've got some section on here, the different video buses that we'll see. PCI. This uses, I'm actually going to move this because I've got a picture of a motherboard down here. And this shows the onboard video. Where's the one with, I had another one. Oh no. Well, there it is. Okay, this is the one I wanted. So I've got a picture of a motherboard here, and this one actually has all three video bus connectors on it, which is great. So you can see you have PCI Express X16, you have AGP, and you have PCI. So if we go back up here, PCI, you can see that is generally white connector. This one actually is strange for AGP. It's orange. It's almost always brown or maroon colored, so I suppose this strange orange tan color got close. But PCI, the throughput on it, you have two different types. You had a 32-bit PCI, and then you actually had a 64-bit PCI. And so it could do 133 megabytes per second or 266 megabytes per second. PCI was not optimized for video at all. It was not a very good option, but for a while there it was better than ISA, so we went with it. Then AGP came out, and this has a range from 266 megabytes a second all the way up to 2 gigabytes a second. We have different flavors of AGP. We have a 2x, a 4x, and an 8x. The 8x gave us the 2 gigabytes per second, and this stuck around for a really long time. This was a great technology. The video cards were very impressive for the time. But then PCIe came out. Now notice PCIe, 250 megabytes a second per lane. So PCIe X16 is what we use for video. Well, how many lanes is that? That's 16 lanes. So 250 megabytes a second times 16 lanes is a lot of data throughput. Up to version 3 gives us 1 gigabyte a second per lane. That math I can do really quickly and easily in my head. That is 16 gigabytes a second. That's a huge difference from 2 gigabytes a second, okay? An 8-fold difference. So, so we are now primarily, we're using PCI Express. AGP has been deprecated. Good luck finding a motherboard with it even on there. But you can see the difference in where the slots are, and you need to be able to recognize this difference. You need to be able to look at these and say, oh, that one's an AGP. So an AGP card is going to be the one that's farthest in on the board. Notice the big gap right here. The PCI slots will be closest to the edge of the board, and the PCI Express will be out here. And you notice the PCI Express has the little spacer over on this side. AGP has it almost in the middle, and PCI has a little spacer over on the far right side. Notice PCI Express and AGP, they both have a locking mechanism for the card on there, and the reason for that is that video cards get very hot. And if we don't have a locking mechanism, sometimes they can sneak out of their slot. Even with the locking mechanism, occasionally they will come a little bit loose. So if you have video issues, one of the things that you want to do is check that the card is seated properly. So just push on it and give it a good shove to make sure it's connected properly. Okay, so what else do we have here? Here's some pictures of some graphic cards. So here's a ATI Radeon 5850. You can see the connectors it has on it. You can see that it has a lot of cooling in here. You've got a fan and you've got heatsink in here. Video cards, like sound cards, they're essentially their own little computer. They've got the GPU, graphics processing unit. They've got memory. There's probably power adapters on the top side of that, or on the back side, probably over here. And then you can see the outputs. We've got DVI, we've got HDMI, and we have DisplayPort, which I neglected to talk about, and I should have. So DisplayPort is an interesting technology. It was designed to be royalty-free. The idea was they wanted to replace DVI and VGA because there's high royalties on those. And so DisplayPort would be a cheaper mechanism for doing that. And it has similar performance to HDMI. And this is the connector. It looks kind of like a USB port, but it's got a little angle right here in the corner that, you know, indicates that it is not a USB port. It's DisplayPort. So if you see that, it's DisplayPort. And go ahead and take a look at our computers in the classroom. You have one monitor connected via DVI, and you have the other monitor connected via DisplayPort, I think. Or is it VGA and DisplayPort? Might be VGA. Because I think our KVM switches don't do DVI. I think they're all VGA. Let's see. So here is another video card, just another example of a different type of heat sinking fan situation. So you can see the heat sink underneath and the fans on top. Dual DVI, and it looks like probably an HDMI connection. Kind of hard to see from this angle. I happen to find the specifications of this particular card. This one's an NVIDIA GeForce GTX 460, and it's got 768 megabytes of video RAM on it. So that's a pretty decent card. The other option is onboard video. So I apparently chose the world's oldest motherboard. No, not really. And it just has onboard VGA video. A lot of, my current motherboard's got onboard DVI, so they come with lots. Some of them will come with, the onboard will even come with HDMI. So installing graphics cards, basically open up the case, pop the card in, put everything back together, fire it up, and then you need to install your video drivers. So you're going to need to know what you have, and you're going to download the drivers, you're going to run the install, and then you may want to do some configuration. And I'm going to give you an assignment to go through and do the configurations. So in Windows 7, which is what I'm running here, if we would like to configure our video settings, we would right-click on the desktop and go to Screen Resolution. And this is going to open this up. I actually have a dual monitor display going on here. So the monitor you're currently seeing is my second monitor. And you can see I have it set at 1680 by 1050, and it says recommended. So that's going to be my native resolution. And then this monitor over here is 1280 by 1024. This is a 4:3 aspect ratio monitor, and this one's a 16 by 9. I have the orientation set in landscape, not portrait. If I flipped it around, I can do it in portrait. I have it set to extend the displays so that I see the desktop on both. And if I click on 2, it says this is currently my main display. When we get back in the classroom, feel free to go ahead and play with this. We've got dual display in the classroom, and you can play around with it. I can do some advanced settings, and if I come in here to the advanced settings, I can, one of the things I can do is the video card will have some sort of application that it installs in order to manage all of your video settings. So most of what you manage here, but even more granularly. So if I open up the control center, I'm going to see all the different options I have for managing my video card. If I go in here to common display tasks, I can do things like rotate the desktop, detect the different displays that I have. I can disable a display. I can set my main display. I can go in here to video. I can actually start messing with the color quality and color options. So I have a lot that I can do with this. And so if you have your video drivers installed properly, you should have one of these control centers in the advanced settings. Another tool that can be handy is DXDiag, DX Diagnostics. You just type in DX DIAG, it's on your definitions, and this will open this up. This used to be a little bit more useful back in the day. It would really put your cards through the paces and tell you what kind of problems you have. So I have a system overview, which is kind of cool. So it's actually going to tell me a lot of really good information about my computer, such as where my BIOS is at, what processor I'm running, how much memory I've got, page file information, what version of DirectX I'm running, my computer name, my version of my operating system, my system manufacturer. Mine says MSI. It's a computer I built, so I'm using an MSI motherboard. And then it shows me information about my displays, my video card in display mode. So this is showing my 4:3 monitor, 1280 by 1024. And my main display over here. If there was problems, it would say, oh, I detected some problems. Like I said, this isn't as robust as it used to be. And then next we can actually look at some of our sound options with DXDiag. It does both. And then it gives me my input information, so my mouse and keyboard. So this is kind of a neat little tool if there's something crazy. This is something that you should think to check if you're having video and sound issues. Tells you your driver information, so it can be useful. So something to know about and be aware of. Okay, so let's talk about a few sound properties. I don't have a lot on sound. Let's see, did I put anything in here? Yep, I got some sound cards. Okay, so sound cards, like video cards, they're like little computers. You have, I put some items on here, DSP, ADC, and DAC. So your DSP is your digital signal processor. This is similar to your CPU and GPU, so it's your sound processor. You have an ADC, which is an analog to digital converter. So it converts analog signals to digital signals. So analog signals would come from the microphone. So any input you're putting in, that's going to be analog, and then converts it to digital. And then you have your DAC, which is your digital to analog converter. And this is going to convert the digital sounds from your computer to analog, so output to speakers. And then you have various jacks on here. You know, this is a very basic video card. I actually chose this. It's old. It uses a PCI connection. And I chose this because of this particular connector on here. You're going to want to know what that is. And this is your game controller. So for a joystick, this is what you would plug in there. Traditionally, you would plug a joystick into your sound card. Line in, microphone, and line out. So this is where you would plug your speakers and your microphone and anything else you wanted to input into your sound. Then I've got a little more modern video card, or sound card I mean, over here. And this sound card uses a PCI Express 1X connection. You can see that right down here. And then this has some more common inputs and outputs on it. So this is a 7.1 surround sound card. And you'll see on here, the first one, the blue one, you have your line in. On this particular card, this actually seconds as a mic input. You'll have your main stereo, so speakers or headphones would plug into the green one. The gray one is going to be your output for your surround sound speakers, and the orange is going to be for your center speaker, subwoofer, and then the black for more surround sound, for more surround sound speakers. And then you have these two square ones, and these are optical ports, SPDIF, Sony Philips Digital Interface, I think. So this uses essentially fiber optic, and this is a really high quality sound option. I remember getting my first DVD player with SPDIF. It was like, oh, this is going to be so great. It's going to be awesome sound. So you have your SPDIF out, you have a digital out, and you have a digital in, which is the black one. And those are, you know, kind of the basic ports, jacks that you're going to see on a sound card. Now this one's 7.1. You can have, you know, the basic 2.1 over here, and your basic 5.1. That's about it. Sound cards are about the same way as video cards. Download your drivers, go ahead and install them. You know, you can have onboard sound. So when it's onboard sound, you have all of the connectors on the computer. And your driver should be included with your motherboard. So drivers, I mean, the device is pretty easy to deal with. You have plug and play, so it auto detects the device, and then you just install the drivers and you're off and running. So that's really the basics of sound and video. If you have any questions, do email me, fill out your definitions, and we will see you in class.